Alright, so today we're going to be talking about a concept called momentum. So, what is momentum? Well, the momentum of an object is given by the equation mass times velocity. So, let's say that I had this mass of n kilograms and it was moving this way at a speed of u meters per second. The momentum of this block would be mu. So, rho is equal to mv, where rho is your momentum and its units are kilogram meters per second. M is your mass in kilograms, and V is your velocity in meters per second. So it's not a very difficult concept. Let's say I had the same body of mass m kilograms moving at a speed u meters per second. And then this same body happens, there's some event, and it changes speed to v meters per second. Now the initial momentum, rho I, is equal to mu, and the final momentum after the event is mv. So if I wanted to find the change in momentum of this object before and after the event, well, the change in momentum is equal to the final momentum minus the initial momentum, which is therefore equal to mv minus mu. And you could even factorize out the m to get v minus u times m. Now, there's this very important law called the conservation of momentum, which states that the sum of momentum, or the total momentum, before a collision is equal to the sum, or the total momentum after the collision. And that's a very useful law when it comes to doing calculations. So let's look at an example. Let's say I had this body A of mass 1 kilogram and it was moving at a speed of 1.5 meters per second. And I have this mass B of 1.5 kilograms, and this one is at rest. What that means is it has zero velocity to start off with, it's not moving. And let's say they collide, and after the collision, both A and B stick together, and we know if they stick together, they'll have a combined mass of 2.5 kilograms. And I want to find out what is this speed after collision? What is the velocity after the collision? Well, using the law of conservation of momentum, we know that the total momentum before the collision is equal to the total momentum after the collision. So we can say that the initial momentum of A plus the initial momentum of B is equal to the combined momentum of A and B after the collision. So we know that momentum is equal to mass times velocity. So the mass of A is 1 times 1.5 plus 1.5, and we know it's at rest, so that means it's times by 0, and that's equal to the mass of the combined body is 2.5 kilograms times v, which is the speed after the collision. And I said I want to find out what v is, so we can go around and we can ignore this term because it's equal to 0. So we can get 1.5 is equal to 2.5 v. So we know that the speed of the combined body after the collision is 0.6 meters per second. Now, one thing that you need to note about momentum is that it's a vector. We know that m is a mass, and we know that mass is a scalar. We know that velocity is a vector. And I've said previously that a scalar times a vector is a vector. So this means that momentum is a vector quantity. So that means that the direction matters when it comes to doing momentum calculations. So let's say I had this time two bodies, A of 10 kilograms, moving at a speed to the right of 4 meters per second. B is of 15 kilograms, moving to the left at a speed of 2 meters per second. And after the collision, we're told that B moves at a speed of 1 meters per second, and it's still of 15 kilograms. And I want to know what is the speed of A. So let's do what we always do and refer to the law of conservation of momentum. We know that the total momentum before the collision is equal to the total momentum after. So we can say that the momentum of A plus the momentum of B initial, let's call it this time, is equal to the momentum of A final and the momentum of B final. Now, I just said that momentum is a vector, which means that the direction matters. It is very important to consider directions. So before attempting to substitute in any values, you need to pick a direction which you're going to say is positive. In this case, it can be any direction. There's no right or wrong. All it means is that your answer is going to be positive and negative, and that's fine because then you can easily identify which direction is actually moving in. So in this case, I'm going to say that to the right is positive. So any object moving towards the right, I'm going to consider having a positive momentum or a positive velocity. So A is moving to the right, so we know that its momentum is 4 meters per second times 10 kilograms. B is moving to the left, so I'm going to say that it's 15 kilograms times minus 2 meters per second because it's moving in the opposite direction. A, we don't know anything about except for its mass after the collision, so we want to find out what its final speed is. And B, we know is moving to the right at 1 meter per second, so this is 15 times 1. So if we simplify this, this will give you 10 is equal to 10v plus 15. And if you rearrange, we're going to get that v is equal to 0.5 meters per second, which means that A is moving opposite to its initial direction. And in this case, it means that it's moving to the left. We talked about momentum, and I'm now going to introduce you to a term called impulse. Impulse is simply the change in momentum, or the final momentum minus the initial momentum. So let's say you had a body of mass m moving at speed u, and then after an event it moves at a speed of v. The impulse, which is denoted by this delta sign, which means this change in momentum, is equal to mv minus mu. And again, you can factorize out the m to get m times v minus u. Now, this is a definition that a lot of people get wrong often. Impulse is simply the change in momentum. Now, when you look at the rate of change in momentum, it is going to simply be the change in momentum over the change in time, or your impulse over change in time. We know that this is going to be m times v minus u over t. And we know that from our Suvat equations, v minus u over t is equal to acceleration. So we can represent this by ma. And we know that ma is equal to the resultant force. So we can get an equation saying that change in momentum over time, change in time, is equal to force. And if we rearrange this, we can get that the change in momentum is equal to force times time. So if a force is exerted on a body over a period of time, the magnitude of that force multiplied by the time is going to result in the change in momentum of that body. Now, the units of force are newtons and the units of time are seconds. So the unit for change in momentum is newton seconds, or it can also be given as kilogram meters per second, as we saw last time. Now, to conceptualize this in a bit more detail, let's say I had a body moving at a speed of 20 meters per second and it weighs 15 kilograms. If I now exert a force of 10 newtons on this body for 5 seconds, now with this information, I can now work out the final velocity of this body, because we know that the change in momentum is equal to the final momentum minus the initial momentum, and that is equal to the force applied on the body multiplied by the time. And before you do any calculations involving momentum, particularly, you have to always state a reference direction. So I'm going to say that the right hand side direction is positive. Now, Our final momentum is given by the mass of the body times its final speed. Well, we know the mass is 15, but we don't know what its final speed is yet. That's what we're trying to find out. So we can just label that as v. So the initial momentum is 15 kilograms times 20. Now we know a force of magnitude 10 newtons acts in the opposite direction of this body. And we've stated that the right hand side is the positive direction. So we have to say that this force is of minus 10 newtons because it's moving or acting in the opposite direction to the moving body, and it's been acting on it for 5 seconds. So now we can rearrange this equation and solve to find v. And we can get that v is equal to 50 over 3 meters per second, and we want to write this as a decimal form, so it's 16.67 meters per second. Now, this is not the only way to solve an equation like this. You could have straight away used F equals ma and then found out the acceleration of this body and then used a Suva equation. They're both the same. Now let's look at a real life example where knowing about force is equal to the rate of change in momentum is quite helpful. So in this situation, you have a car moving at 60 miles an hour and it's going to crash into a wall. And the question in this case is going to ask, what is the importance of an airbag in a car? We know that airbags are installed in cars. What is their purpose? Now, I don't recommend you trying this yourself, and please, most people driving at 60 miles an hour will probably not get out of it unharmed, so don't try this at home. So what is the purpose of this airbag? So we know that when this car crashes, it's going to stop, and it's going to be crumpled up, and it's going to have a speed of 0 miles an hour. So we can therefore say that it has a change in momentum, it has an impulse acting on the car because it changes speed. And we know that the force exerted on the body is equal to the impulse over time. So we can say that the force is equal to change in momentum over time, which is therefore equal to mv minus mu over t. And what the purpose of an airbag is it increases the amount of time it takes for the car to decelerate. So what that means is the force is going to be acting over a longer period of time. This t value here is going to increase. And the impulse on this car is going to be the same, regardless of if there's an airbag or not. But the time taken with an airbag is significantly greater. So what that's going to do is if you increase the time taken here, you're going to end up decreasing the force. So an airbag causes longer time for body to come to rest. So the value of change in momentum over change in time is less. And therefore the force exerted is lower. That's why there's features in the car called the crumple zone, the airbag, and a seatbelt, because it increases the time taken for you to slow down, and it therefore reduces the force exerted on your body. So you're more likely to walk away with less serious injuries. The last thing I want to talk to you about is a force versus time graph. And these can have any shape whatsoever, and it could look maybe something like this. One thing that you have to bear in mind with a graph like this is you need to understand that the area under this graph is equal to our force multiplied by time, and we know from our equation that we just learned is the impulse. So the area given by this graph is equal to your impulse. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.